Welcome. In this video, we'll introduce the Optical Time Domain Reflectometer, or OTDR, a crucial tool for anyone working with fiber optic networks. The OTDR is designed to characterize fiber optic spans, which are typically sections of optical fiber joined by splices and connectors. By sending short pulses of light into the fiber and analyzing the returned signals, the OTDR can calculate the fiber's length, attenuation, breaks, and total return loss, as well as losses at splices and connectors. This inside view of the fiber helps technicians quickly identify faults and ensure the network's integrity. Throughout this guide, we'll explore the OTDR's main features, safety considerations, and essential setup steps to help you get the most accurate results from your fiber testing. Let's take a closer look at the different OTDR models and their main interfaces. EXFO offers several OTDR series, including the MAX 700B, FTB 7000, FTB 720, FTB 730, and MAX 700C, each tailored for specific testing needs. These units feature ports for single-mode and multi-mode fibers, active LEDs to indicate laser emission, and optional visual fault locator (VFL) ports. The main window of the OTDR application is designed for clarity. You'll find a graph overview, data display, button bar, and an event table that summarizes detected fiber events. The interface may vary slightly depending on your device's screen resolution, but the core layout remains intuitive. Understanding your OTDR's hardware and software layout is the first step to efficient fiber testing and troubleshooting. Now let's dive into how the OTDR works. The OTDR sends short laser pulses into the fiber. As the light travels, it encounters discontinuities like splices, connectors, bends, or faults, which cause some of the light to scatter or reflect back. The OTDR detects this backscattered and reflected light, analyzing the signal's strength over time to pinpoint the location and type of each event. Two main physical effects are at play: Rayleigh scattering, which causes light to scatter in all directions due to microscopic variations in the fiber, and Fresnel reflection, which occurs at abrupt changes in material density, such as at connectors or breaks. The OTDR measures the time delay between sending and receiving the pulse to calculate distance, using the formula distance equals c times t, 2 times n, where c is the speed of light, t is the time delay, and n is the fiber's index of refraction. This process provides a detailed map of the fiber's condition. Before you start testing, safety is paramount. Always ensure that no light source is active when installing or terminating fibers, and never look directly into a live fiber. Many OTDR units use Class 1M, 2, or 3R lasers, which can be hazardous if viewed with optical instruments or directly. Check the labels on your device for laser safety information and always follow the manufacturer's guidelines. Next, prepare your OTDR for testing by installing the correct EXFO Universal Interface (EUI) for your connector type APC or UPC. Clean all fiber ends thoroughly using lint-free swabs and isopropyl alcohol, then inspect them with a fiber inspection microscope. Proper cleaning and handling prevent measurement errors and equipment damage. Once everything is clean and connected, you're ready to configure your OTDR for accurate testing. With your OTDR and fibers ready, it's time to configure your test. Start by setting the index of refraction (IOR), Rayleigh backscatter (RBS) coefficient, and helix factor. These parameters ensure accurate distance and loss measurements. You can also set detection thresholds for splices, reflectance, and end-of-fiber events, as well as enable macrobend detection to spot fiber bends. Next, configure pass-fail thresholds for splice loss, connector loss, and other key parameters. When ready, connect the fiber to the correct OTDR port, select the desired test wavelengths, and start the acquisition. The OTDR will analyze the fiber, display a trace graph, and summarize detected events in a table. You can save results for further analysis or reporting. By following these steps, you'll ensure reliable, repeatable fiber tests every time.